In this video, we are going to recap the method of Lagrange multipliers. So we said that the whole thing about Lagrange multipliers was that we wanted to optimize this function of two variables, f of x comma y, subject to some constraint, g of x comma y equals 0. So these are the steps. So if you want to take a moment to pause it, you can copy down the steps. So the first thing that you want to do is find the Lagrangian, which is basically a combination of f of x comma y and g of x comma y with this lambda multiplied to g of x comma y. The second step is to set all your partial derivatives. So take the partial derivative of this f function with respect to x, y, and lambda and set them equal to 0, and you're going to solve for them. So in particular, what you're going to be solving for is what is x equal to and what is y equal to. Okay, and then number 3 is the solution to the original problem will occur at one of these critical points. So basically what we're going to do is that we are going to get these x and y's, and then we're going to plug it back into our f of x comma y. Okay, so let's go ahead and do a problem. We did one in class, but let's go ahead and do another one. So one that's a little bit more general. So here is my example. So use Lagrange multipliers. Let me just write LM for Lagrange multipliers to maximize the function. Okay, f of x comma y, subject to the constraint. Okay, and here is going to be my function f of x comma y is equal to 6xy, and then my constraint is going to be 2x plus 3y is equal to 24. Okay, so you can try it out if you want to, or you can just follow me along. So the first thing that you want to do is that we want to set up the Lagrangian. Now, if you notice here, in order for me to set up the Lagrangian, I need an f of x comma y, which I do, but I need my g of x comma y to be equal to 0. Okay, so at this point, here's my g of x comma y. This is not set equal to 0, so let me move the 24 over. So I'll have 2x plus 3y minus 24 is equal to 0. Now next, what we want to do is set up this Lagrangian. So we know that the Lagrangian should be f of x comma y comma lambda should equal to f of x comma y plus lambda g of x comma y. Okay, and all we're going to do is just plug it in. So f of x comma y is just this guy, 6xy, plus lambda times g of x comma y, which in this case is this guy right here. So 2x plus 3y minus 24. Okay, so let me go ahead and distribute this and clean it up a little bit. So I have 6xy plus 2x lambda plus 3y lambda minus 24 lambda. Okay, so we basically found the first part, which was finding the Lagrangian. Now we're going to set the partial derivatives and set them equal to 0. So here is step number 2. Let me write it in a different color. So step number 2 would be to find the partial derivatives. So I'm going to first find f sub x. Okay, so taking the partial derivative of this guy is going to give me 6y. And then this guy is going to be plus 2 lambda. Oops. So plus 2 lambda. Okay, that one we're going to set equal to 0. Then we're going to take the partial derivative with respect to y. Okay, so that's going to give us, what is this? This is going to, so this guy's going to, the y goes away, 6x plus 3 lambda equals 0. And then we're going to find f lambda. Okay, and then this guy's going to be 2x plus 3y minus 24. And I'm going to set that guy equal to 0. Okay, so now I have these system of equations. We have 3 unknowns and 3 equations, so we can solve this. So the first thing that we want to do is, what I like to do is solve for y and x using my first 2 partial derivatives. And once I have some sort of relationship between x and y, I plug it into my f of lambda. So first, let me go ahead and solve for lambda first. So let me solve for lambda. Okay, so I'm going to have 6y plus 2 lambda is equal to 0. I'm going to move the 6y over, so I have 2 lambda is equal to negative 6y. So lambda is equal to negative 3y. Okay, and now I'm going to solve for this guy. So this one was for this guy. This one's for this guy. So I'm going to solve for lambda again. And this one's going to be 6x plus 3 lambda is equal to 0. Move the 6x, I'm going to have 3 lambda is equal to negative 6x. So lambda is equal to negative 2x. Okay? So now because I know that lambda equals negative 3y and lambda equals negative 2x, these guys must be equal to each other. So negative 3y is equal to negative 2x. At this point, you just want to solve for any variable that you want. You can be x or it can be y. Let me just solve for y. So I'm going to divide by negative 3. So y equals 2/3 x. Okay, so now we have a relationship between x and y. So now what we're going to do is that we're going to go ahead and plug it into our third equation that we haven't used yet. So I'm going to plug it in here. So here I'm going to have 2x plus 3y minus 24 is equal to 0. So what I'm going to do is I'm going to plug in y equals 2/3 x in there. Okay, so what I'm going to have is, let me write it in a different color. So I'm going to have 2x plus 3 times 2/3 x minus 24 is equal to 0. Okay, so now I'm going to have 2x. Here the 3's cancel out, so I have another 2x. Then I have minus 24 is equal to 0. So 4x minus 24 equals to 0. 4x equals 24. And I divide it over, so x equals 6. Okay, so we finally got a solution. All right, now that I know that x equals 6, all I got to do is just figure out what y is. Now, what would be easy would be to just plug it in here. So I'm going to have y is equal to 2/3 x. So now I'm going to plug in that 6. Okay, and what I'm going to get is 4. So my critical point, okay, in this case would be 6, 4. Okay, that's my x and that's my y. Now, because we want to look at the original function, and what we really want to do is maximize the function, we know where the maximum is going to be. It's going to be at this particular point, at 6, 4. Now, what is the maximum? All you got to do now is do step number 3. And step number 3 basically is solve. Oh, I'm sorry, not solve. Plug in. Okay, so that's my third step. Just plug it in. So my original function, f of x, y, is equal to 6xy. All I'm going to do is I'm going to plug in the 6 for the x and the 4 for the y. I'm going to have 6 times 4. And what I'm going to get is 144. So this guy is going to be my maximum. Okay. All right. So this is basically all there is to it. The steps are very are still the same for regardless of any problem. The only one that does take you a little bit of a while is number 2, setting them equal to 0 and then solving for the equation. But other than that, it's very self-explanatory. We'll do another problem that's a little bit more difficult, and then we'll do another word problem.